All right, in this little mini lesson, we're going to talk about how to use SPSS syntax to calculate simple main effects and simple comparisons after a factorial design. So we're using artificial data, and these IVs are chosen rather arbitrarily, but we have two IVs. We have level processing, low, medium, and high, and sound level 10, 50, and 100 decibels, and our dependent variable is the number of errors. And what we're interested in is the simple main effects of level of processing at each decibel level. So we could say, are there statistically significant mean differences in number of errors as a result of level and processing, low, medium, and high, for people who hear 10 decibels. So we're doing like a little mini ANOVA just on these three cells. We could do the same thing and look at just people who have heard 50 decibels of sound. And again, a little mini ANOVA here, and finally a little mini ANOVA here. So we've got little mini ANOVAs for these simple main effects. Another way to look at this is to say, does a sound level moderate or change the relationship between level of processing and number of errors? So to do that, essentially what we're doing, if you're doing this by hand, or you could do this umpteen zillion different ways in SPSS, we're doing a little one-way ANOVA at each of these levels. As an aside, and not shown in this video, we could also do the simple main effects, looking at decibel levels and errors at each level of processing. We're not doing that in this video. To set this up in SPSS, and there are a number of ways, I'm just showing you one way, we're going to do it so that we get both simple main effects and we also get comparisons done at the same time. So here are the weights for our first comparison, and we're going to compare low, the two, versus medium and high combined. So our hypothesis is, are there significant mean differences in number of errors between those who hear low, who do low processing, versus those who do medium and high combined? And then our second comparison will compare number of errors between those who do medium processing versus high level processing. So these are the same kind of coefficients you used for any old one-way design, one-way ANOVA, when we were comparing means. We're just going to apply them to just one level at a time. They should be orthogonal if we want to extract maximum information. So you might be asking yourself, well, if I'm showing you how to do this in SPSS, why are we spending so much time in Excel? Well, I'll tell you. Because when we set up the syntax in SPSS, it's really nice to have sort of set up a grid for yourselves, so that it's very easy to input the coefficients and sort of minimizes the number of errors. So let's just step back and think about this for a minute. If for this first, let me change this back to, like any video, I've done a zillion of them before I got one right. So let me just make one little edit. You've all been there. You know how it is. Okay, so 10 decibels. We want to do this simple main effect of level of processing for people who hear a sound level of 10 decibels. So we want to use this comparison and only these people. So we just put that in. We put the coefficients in, put them in the cells, and we don't want to use any data from people in the 50 decibel level group or the 100 decibel level group. So how do we get rid of that? Thinking these are weights? Well, we want to put a zero weight to their mean. So just put zeros in. And recall that when we're calculating these, if you were calculating these by hand, you would be multiplying each coefficient by the mean to weight the means. And these coefficients obviously directly translate, they specify actually, the null hypothesis for each thing you're doing. So if we have our comparison and we use this orthogonal set of comparisons, we specify the first one here, and then we've got comparison 2. Before I put it in, why don't you go ahead and pause the video and see if you can put in, how would you put in these comparison weights? Just take a minute and do that. And now that you've done that, you can feel brilliant because you're seeing that it's just the same thing. We don't care about the people in the 50 decibels, so we're going to zero them out. We don't care about, at least for the purposes of the simple main effect, the people in the 100 decibel levels, so we're going to zero them out. So these are weights, and we use them for weighting the means in comparisons. And since we used our orthogonal set together, they will add up sum to the sum of squares for the simple main effect. And remember, you can do as many orthogonal comparisons as you have degrees of freedom for the IV. So here we had 3 levels, so we had 2 degrees of freedom. So 2 orthogonal comparisons. All right, so that is for the 10 decibels. Let me get all of this. You can anticipate we're going to do one more. Let's do 50, and then we'll move on over to SPSS, and you'll see how why this was good to have. So keep this out. Hopefully you've got this on like a little piece of scratch paper or something, or when we move over to Excel, you'll be able to see how that works. Actually, we'll move over to, you're in Excel, we'll move over to SPSS, so we'll be able to see that. Okay, so let's do the same thing for 50. I want you to start thinking that through right now about how you would do that. All right. And the glory is with the video, you can pause it and think. So with 50, we no longer want to use data from the 10 milligram people. So, or 10 milligram, boy, absent-minded professor, 10 decibel level people. But we do want the 50. So we've got 2 minus 1 minus 1. And we don't care about the data from the 100 decibel people. And the second comparison is this, again, for the 50, for the simple main effects of level of processing on number of errors for those who have heard a sound at 50 decibel levels. We don't care about the people who heard the sound at 10 decibel levels. But we do care here. And now we're comparing the people who did the medium to the high processing. And we don't care about the people for these purposes only, at the high decibel level. So we did this for 10 decibels. We did it for 50, and you could do the same thing for 100 decibels. So why does this matter? Well, just as we use these simple coefficients when we had a one-way ANOVA and wanted to calculate comparisons and weight the means, we're going to use all of these when we want to calculate simple main effects and also get simple comparisons. We'll use all of these, both of these sets. So if we go over now to SPSS, and we do our standard, and obviously, there's lots of ways to do this, but let's pop over number of correct answers, level of processing, decibels. Again, not critical for simple main effects. I just like to look at these. And then we're going to get to syntax by clicking on paste. You can go directly to paste if you want to. Directly to syntax if you want to. You don't have to go this way, but this sets up some of it for you already. So we go to syntax, and this is what you would see. you would only see the part I've highlighted. I'm trying to sort of streamline this for you. And you can see that this section here matches exactly this section right here. The new part is this L matrix stuff. Notice that the L matrix comes in between. I'm just keep this out for simplicity. This L matrix is inserted after the criteria and before the design. So let's just move this out of the way and just chat about what this is. First thing, and you know if you're using syntax, that it's got to be exact, because SPSS doesn't know that, oops, you meant to put something down and you made a little typo. So there's well worth your time to double check and check. So we've got our DV and then our IV1 process in decibels, standard stuff here. And then this is an L matrix. And the first thing that's nice is to give this a name. So we're going to calculate the simple main effect of process for decibels 10. And then just jump down with me. Simple main effect of process for decibels 50, and jump down. Simple main effect of process for decibels 100. These are in quotes, so you can really put anything you want to in the quotes. Now, you've got that piece of scratch paper, you've got something there with the work we did in Excel. We want to do the simple main effects of process across levels of sound, and we had our two comparisons. Well, lo and behold, here they are. So we've got process, it was up here, process the first one, process here, 2 minus 1 minus 1, and then we need to tell SPSS by this process by decibels that we're decomposing the interaction. And then before we go to this section, let's look over here. Then again, here's the IV we're going to do the comparison on, and our effect, and together these are the simple main effect. And again, we're going to compare the medium to the high level of processing. Now, these are the overall comparisons, but we need to get them into that. We need to put the weights in there for that little 3x3 matrix we had that you've got right next to you that you're looking at. So let's look at this. 2 minus 1 minus 1, process by decibels. So we want to compare, first we want to compare low level of processing at 10 decibels. Now we're going to go down the columns. We don't care about, so we put a 0 in low level of processing 50 decibels and a 0 for low level of processing 100 decibels. Then we go back up and we've got -1 for medium processing 10 decibels, 0 for medium processing 50, 0 for medium processing 100 decibels. And then we pop back up to the third column and we've got -1 for our high level processing at 10 decibels, and 0 for high processing 50, and 0 for high processing at 100 decibels. And notice you have to finish that with a little semicolon. So this is the bizarre thing. We have this comparison and we enter it by going down columns. So first we have the first column is for low processing, the next column down medium processing, and high processing. So like look at that sheet you made for yourself. And the same thing follows here. We do the second one here. And again, we're not using low level processing at all. So that column is all zeros. And since we're at 10 decibels, we've got 1, 0, 0, and then -1, 0, 0. That follows through for the 50. Again, you don't have to do the same comparisons all the way through, but I think it's nice. Often you want to, but there's no reason you have to. It should be orthogonal. And again, so now we've just shifted. Now we're into 50 decibels. So we don't care about low level of processing at 10 decibels, but now we're comparing the second entry in each column. So These first three are the first column, second three are the second column, last three are the third column. So this is why it's really great to have that little matrix even sketched out on a piece of scratch paper, and not to try to have to think about it when you do it. So process follows the data entry follows as is written here. And then you finished with the design, which was there. You want to do the main effective process, the main effective decibels, and process by decibels. And there's a little period there. Things that people miss: the semicolons after the first comparison, or before the last one, the period right there. Anything you accidentally misspell, if you're a typo queen like me, there will be a lot. So it's imperative that you double check. And trust me, SPSS gives you error messages when it doesn't. So there's lots of ways you can run syntax. I generally just highlight what it is, and click there, and voila, we have our output. And I'm going to show you a couple things. There's just the overall tests. But I want to show you this, because if I ran the world, I would organize this differently. This is our first test. This first one, remember, you have to go back. The first one was for, and it tells you, simple main effects of process for decibels 10. So custom test 1 is our first simple main effect. However, SPSS flips it. Here, this is 2 degrees of freedom. Here's the simple main effects right here. And then, and it's significant, and you can tell this is fake data because our eta squared is gigantic size. And just so you know, this is not 0. This is something less than 0.000. And then here, though, we have our comparisons. Here's comparison 1, and that comparison compared our low versus medium and high combined. And this comparison compared medium versus high. And here's the significance level. The first one was significant, the second one was not. So in my perfect world, if I were telling SPSS how to do this, I would flip it. I would put the simple main effect first and then follow up with the comparison. But that's not the way it's presented. So we have the second one, and we pop down, and for the second, they look the same. Here's the simple main effect of decibels 50. And here is the simple main effect, the overall test. And you know that because it's 2 degrees of freedom. Here are the comparisons that are associated with it. And then finally, we have our third test, and it's here in the little print, 100. And here's the simple main effect, and there are comparisons. And then I plotted it so that you can see that these were the simple main effects we were doing. So this is sort of a fast run through of taking the development of coefficients, taking that and beginning on Excel, just so you have a little worksheet, taking that and putting it into SPSS, and then slight little tips for working with syntax and how you then go about interpreting it, how you find things. So I hope you found this helpful, and good luck and take good care.